Hello everyone, welcome to my channel. In this video, I will discuss one more problem on supermesh analysis. Determine the loop currents for the circuit shown by using mesh analysis. Let's write step 1. Step 1 is to identify number of meshes. I'll consider this as mesh 1, this as mesh 2, this as mesh 3 and this one as mesh 4. Number of meshes equal to 4. Step 5, to assign mesh currents. I1, I2, I3, this is I4. I have assumed all currents in clockwise direction. If you want, you can assume in anti-clockwise direction as well. I'll write here assigned currents are I1, I2, I3 and I4. Step 3. In the circuit, you can observe that current source is present between two meshes. Even here, 5 ampere current source is present between two meshes. So we can apply here super mesh analysis concept. When a current source is present between two meshes, you always look for the procedure under concept of supermesh analysis. In supermesh analysis, step 1 and step 2 are same as mesh analysis steps. Identifying number of meshes is the first step. Second step is to assign mesh currents either in clockwise direction or in anti-clockwise direction. And step 3 in supermesh analysis is look for the meshes which does not contain current source. Then apply KVL to that mesh. Identify, let us see the mesh 1. Here we have a current source and in mesh 2 again we have two current sources, and in mesh 3 we have a current source, and in mesh 4 even we have a current source. So we don't have any mesh which does not contain current source, so we can skip step 3. Next, step 4. Step 4 is remove the branch having common current source between the meshes and then apply KVL to supermesh. We'll just remove the branch here 20 amp and 5 amp and redraw the figure. Ten volts, 1 ohm, 4 ohms, 20 volts, 8 ohm, 30 volts, this is 20 ohm, 15 amp, 16 ohms, 10 ohm. Show the currents I1, I2, I4 and this is I3. We have removed the current sources which forms a super mesh here. Let us see here. Let us write a point. Meshes 1, 2 and 4 forms super mesh. Let's apply KVL to this super mesh. I'll start with 10 volts. Minus 10, next 1 ohm, plus I1 plus 4 ohm, 4 into I2, 20 volts, minus 20, plus 8 ohms, plus 8, 4, minus 30, next plus 20 into I4 minus I3 plus 10 into I1 minus I3 equal to 0. I have applied KVL to supermesh. By applying KVL to supermesh, I have got this equation. I'll just rearrange the terms and I'll write this equation as 11I1 plus 4I2 minus 30I3 plus 28I4 equal to 60. Let this be equation number 1. Step 5 is to write the net currents in current sources. Step 5 is to write net currents in current sources. Let me take each and every current source. From the figure, let me start writing with 5 ampere current source. Here I1 is flowing and here I1 and I2 are flowing in reverse directions. Let me start with writing 5 amp, I1 in this direction and I2 in this direction. Write the net current I2 minus I1 equal to 5. The current flowing in the direction of current source is treated as greater than the other current. So I can write net current as I2 minus I1 equal to 5. Let it be equation number 2. Next current source 15 amperes. Only I3 current is flowing in 15 amperes from the figure. You can see here this is 15 amperes. Only I3 current is flowing in this current source. I have indicated the same. Therefore, net current equal to I3 equal to 15. Let this be equation number 3. Next current source 10 amperes. From the figure we can see I2 is flowing in the same direction and I4 is flowing in reverse direction. I can write the net current as I2 minus I4 equal to 10. Let this be equation number 4. We have 4 equations and step 6 is to solve the KVL equations to find the mesh currents. Solving equations 1, 2, 3 and 4. Mesh currents will be obtained like I1 equal to 14.65 amp, I2 equal to 19.65 amp, I3 equal to 15 amperes, I4 equal to 9.65 amperes. This is how we can calculate the mesh current. Let's discuss one more problem on super mesh analysis. For the circuit shown in figure, find the current through the 10 ohm resistor by using mesh analysis. Step 1 is to identify number of meshes in the given circuit. So we have here one mesh, this is second mesh, this is third mesh. Let it be 1, 2 and 3. Number of meshes equal to 3. Next, step 2 is to assign mesh currents. Let this be I1, let this be I2, this be I3. I1, I2 and I3 are the assigned currents in the meshes. And here you can see between two meshes we have a current source here. So we can apply super mesh analysis concept. Even here you can see a current source between mesh 2 and 3. This is an dependent current source. Okay. So from step 3 we'll apply the concept of super mesh analysis. In supermesh analysis, step 3 is to look for the meshes which does not contain any current source and then apply KVL. In the circuit given, we don't have any mesh which does not contain any current source. So step 3 is simply ignored. Step 4. We have to remove the branches having current sources and then apply KVL. Let me redraw this figure. Fifteen volts, 10 ohm, 20 volts, 5 ohm, 4 ohm. This is 40 ohm. Current flowing will be as it is, I1, I2, I3. After removing the current sources, this is how the circuit will look like. Meshes 1, 2 and 3 forms super mesh. Step 4 is to remove the current sources between the meshes and then apply KVL to the super mesh. Let us apply KVL to the super mesh. Applying KVL to super mesh, we get, I'll start with 15 volts, minus 15 plus 10 into I1 plus 20 plus 5 I2. Next is 4 ohm resistor here, plus 4 I3 minus 40 equal to 0. This is the KVL equation obtained for supermesh. Let us rewrite the equation. I can write 10I1 plus 5I2 plus 4I3 equal to 35. Minus 15 plus 20 minus 40 is nothing but minus 35. If you make this to come on right hand side, we'll get equal to 35. Let this be equation number 1. Step 5 is to write the net currents in current sources. Step 5. Let us write the net current in this 2 ampere source. I1 current is flowing like this and I2 is flowing in reverse direction. Two amp, I2 is flowing in reverse direction, I1 is flowing in the same direction. We can write the net current as I1 minus I2 equal to 2. The current which is flowing in the same direction as 2 amps will be treated as greater current than the other current. So we can write net current as I1 minus I2 equal to 2. Let it be equation number 2. This is also a current source. We can write the current equation for this source. This is dependent current source. Same concept is applied even to dependent sources. I2 is like this, I3 is like this. We can write net current as I3 minus I2 equal to 2I1. Let this be equation number 3. I'll just rewrite this as minus 2I1 minus I2 plus I3 equal to 0. Let this be equation number 3. No more current sources are left in the circuit. We'll just move on to step 6. Step 6 is solving equations 1, 2 and 3. Mesh currents or I1 equal to 1.96 amp, I2 equal to minus 0.03 amp, I3 equal to 3.8 amps. These are the mesh currents obtained after solving equation 1, 2 and 3. Let's see the question. We are asked to find the current through 10 ohm resistor by using mesh analysis. You are supposed to find the current through this 10 ohm resistor. If you observe the circuit, the current flowing through 10 ohm resistor is I1. In step 6, we got I1 as 1.96 amps. So current through the 10 ohm resistor is given by I1 equal to 1.96 amperes is the answer. That's all for this video. Thank you.